So let's look at some computational examples to help with the week 5 homework. So first off, here we had a researcher who suspects that the actual prevalence of obesity among children is lower than the previously reported prevalence of obesity among children and adolescents. So the previously reported here was 28.2%. So prevalence here is a proportion or a percentage. So this is going to be a hypothesis test for P. Let's see here. We examined medical records of 255 children. That is your sample size. So N is 255. And the researcher determined that the prevalence from those in the study was 27.1%. So that's going to be your P hat, will be 0.271. Test the hypothesis for a level of significance of 5%. So alpha is 0.05. So now the homework problems that are similar to this one is to actually split up in pieces. But your step one is to state your null and alternative hypothesis. So our null is that it's not different than previously reported. So P equals 0.282. Now the researcher suspects that it's lower. So our alternative will be P less than 0.282. And then our decision rule at alpha equal 0.05 will be to reject the null if Z is less than negative 1.645. That's table 1C in the appendix. So if we look at that table, here's table 1C. It is a lower tailed test. Alpha is 0.05. Right there is the negative 1.645. So that's where that comes from. Now, alternately, we could use P less than 0.05. That's okay too. Step 3, compute our test statistic. So we're going to do this with the Excel online workbook. So I've opened that up. And you'll see lots of tabs along the bottom here. Test for M summary data, test for P summary data. And we actually want that fourth tab. This is a hypothesis test for proportion, and we're given the summary data. We're not given number of successes. So our level of significance, 5%, don't need to change that. Proportion under H0, that is the 0.282. So it's only displaying 2 digits, even though we put in 3. And then that is right here. And then our sample proportion, 0.271. N here, N was 255. So 255. And then number of successes were not given, but we are given sample proportion, 0.271. Enter. So we see that our test Z value, our test statistic is negative 1.39, and our one-sided p-value 0.348. So that is where I got this, Z negative 0.39, and P is 0.348. So you can also compute those by hand, but it's much less work to use and probably more accurate, because it's less likely you'll make mistakes, to use the Excel online workbook. Step 4 is to state your conclusion. So our test statistic is negative 0.39, and that is greater than equal negative 1.645. So we would fail to reject the null hypothesis. It's not more extreme. Or our p-value of 0.348 is greater than 0.05. So again, we fail to reject. So we would say there that we do not have statistically significant evidence to show that the prevalence, the actual prevalence, is below the previously reported 28.2. Next example. We've got a new drug to treat COPD that's been developed and is in clinical testing. We're assuming the individuals given the drug are examined before receiving and then again after. So it's a before and after test. And let's see, we're trying to determine here if there was a change in their symptom status. So the initial results showed 3% of the individuals entered the study in remission. 54% had mild symptoms, 24% had moderate, and 19% had severe symptoms. we're going to calculate and interpret a chi-squared test at the 0.05 significance level to determine if the drug was effective. So if the drug's effective, then the percentages here should change. Of course, it would need some extra interpretation to decide if they changed in a positive manner or a negative manner. So, but we're going to conduct a chi-squared goodness of fit test, because we're going to test and see if these are the after numbers from the total sample size of 1,000, and we want to see if those obey this distribution of 3%, 54, 24, and 19. So we will start off here by stating our null alternative. So H0 is that distribution of severity of COPD cases at the end is not different from the distribution of COPD prior. So there's no change. The drug has no effect. H1 is going to be the distribution of severity of cases at the end of the clinical trials is different. So there is a change from cases from the distribution prior. Step 2, we're going to state our decision rule. So our degrees of freedom here are going to be k minus 1, where k is the number of groups. So 4 minus 1, 3. And then alpha is 0.05. And if you look in table 3 in the appendix, we're going to reject H0 if chi-squared is greater than 7.81. So here's that table. Our degrees of freedom right there are 3. Alpha is 0.05, and the intersection of that row and column is the 7.81. So that's where we got this number. Alternately, if p is less than 0.05, which is our significance level right here. Step 3, compute our test statistic. So we can do that, test statistic or p-value. We can actually do that using the online workbook for chi-squared. So let's go ahead and take a look at that. So here's what that workbook looks like. We've got a chi-squared GOF, goodness of fit, and a test of independence. We want the goodness of fit because we're testing against a distribution. So number of response options, they call that K. That's your number of categories here, which in our case was 4. 1, 2, 3, 4. So that's going to be a 4, enter. And then the number of participants that are in each group, so that's going to be your observed values. So that's the values in the table: 66, 625, 214, and 95. So 66 here, 625, 214, and 95. And your double check down here, we've got a total sample size of 1,000. Expected proportions, that's what we're testing against. So that's up here, the 3%, 54, 24, and 19. So as decimals. So 0.03, 0.54, 24, and 19. So 0.24, 0.19. And that gives us a test statistic of 106.896, so 106.9, and a p-value of 0 to 3 decimal places. So that is how I got our chi-squared 106.9 and p equals 0. That was from the Excel online workbook. State our conclusion. Well, since the 106.9 is greater than 7.81, or our p-value is less than 0.05, either one of those, we say that there is statistically significant evidence to reject H0. So we're going to conclude that the distribution of severity of cases at the end of the clinical trial is different. So there was an effect on this drug. So we would need to analyze and make sure that it's a favorable change. So this chi-squared has just told us that there is a change. So definitely drugs make it a difference. And we hope it's not going to make things worse. Third example here, We've got a researcher that recruits 100 Asian and 100 Hispanic individuals, so 2 different populations. They are taking a medication here, Pixpan, and they want to determine if there's a difference in the mean dosage of the medication needed to cause a decrease in their INR blood test. So the mean dosage for the 100 Asian individuals was 7.4 milligrams. Standard deviation was 2.1. So here's 7.4, sample standard deviation 2.1, sample size was 100. For the second population, they needed 9.7 milligrams with a standard deviation of 1.7. So that's our second mean, sample mean, second standard deviation, sample size still 100. So we want to know what should the researcher's conclusion be at the 5% significance level. So we're trying to test if there is a difference here. So this is a two-tailed test. We are testing means. So our null hypothesis is going to be the 2 means are the same, Asian and Hispanic. So mean 1 equals mean 2. So that mean dosage does not differ. There is no difference. The alternative is a two-tailed. Mean 1 not equal mean 2 because this says difference. Doesn't say greater or lower. Step 2, decision rule. So table 1C will give your critical value of 1.96 for a two-tailed. So if we go back here to our table 1C, so 1C, lower tail, upper tail, got to come down to a two-tailed test here. 0.05 right there, 1.96. So that's how we got this value. This critical value. So two-tailed tests, an equal, not equal, you would reject if Z is less than equal, negative 1.96, or greater than positive 1.96. Remember the Z value, that test statistic, that's the Z score of our sample evidence. So if it's too big or too small, it's too extreme to be due to chance. So we'll go ahead and compute our test statistic, again with the Excel online workbook. So we're testing 2 means here. So if we go back to our workbook, so let's see, I'm sorry, that one is chi-squared. So we want a difference of 2 means. So mean difference summary, mean 1 minus mean 2 from data, or mean 1 minus mean 2 summary. That's the one that we want. Let's make that a little bit bigger. So our significance level, alpha 0.05, so 5%. The difference in the means under the null hypothesis is 0 because we're testing if they're equal. Our 2 sample sizes here were 100. And then our first mean and standard deviation were 7.4, 2.1. And then our second mean and standard deviation, 9.7, 1.7. And you see here our Z value, our test statistic, negative 8.51, and our two-sided p-value 0. So Z is negative 8.51 or P is 0, either one of those. That's Excel Online Workbook, tab 8. And then our conclusion, well, that negative 8.51, that's less than negative 1.96, or our p-value is certainly less than 0.05, so we're going to reject the null hypothesis. So we conclude there is sufficient evidence to accept the alternative hypothesis, which is saying the means are not equal. So that means that the mean dosage of the drug differs between Asians and Hispanics. So as you're doing homework in the section, you want to try to use the Excel Online Workbook as much as possible. And that is a resource that you can use on the quizzes and on the exams.